Welcome everybody, wherever you might be. We have people all the way from where I am in New York City, all the way to Australia and Japan. So wherever you are, welcome. So this is the first day, part one of the Designing Smart Building Systems workshop. It's been divided into 6 parts, as I mentioned, half-hour sessions. The first week will be hosted by myself. We will be going deep into smart building automation. I have 2 wonderful guests. Today I have Michael Anselmo from Acuity Intelligent Buildings. I have tomorrow Russell Horowitz from Somfy Blinds. And week 2, we have the Acuity Brands lighting team. So they'll be talking about integrating lighting into the BAS system. We have with us Chase Anderson and Bo Chen from Acuity next week. And then in week 3 for the sessions, we have Marcello Luisi from Tridium. He will be talking about their Niagara platform and large integration projects and how to specify for large-scale systems integration. So through the 3 weeks and through the 6 sessions, you are going to get a full spread of how to design a smart building, all the way from its components, from a BAS system, IoT platforms, blinds, lighting, and ultimately large-scale system integration. I just want to give Michael an opportunity to say hi. He's somewhere here. Michael, are you there? I think you might.
Yes, I am. Hello.
How are you?
Very good. I'm excited to be here with you today and give a little bit of insight into what Acuity's intelligent building platform and what an IoT platform should be.
Absolutely. Michael's here in Brooklyn. I'm here in Queens, and that's kind of our program for the next 3 weeks. Now, those who have asked for PDH credits, you have probably checked the box at the sign-in. You will be getting your credit certificates automatically, and Pi will be notified of your attendance. Now, if you have forgotten to check that box and you still need those credits, just reach out to us after the workshop is over, and we will be able to facilitate that for you. So with that being said, let's get started. So today's agenda is really to set the foundation. Any good house needs a strong foundation, and we will be going through the building blocks of a smart building, namely a smart BAS system. I will be touching on things like how the OT world, which is the world that people like me occupy, the operations technology world, where we connect machines in a building together, is converging with the larger IT world, which is the software and application world, and how that is pretty much drawing our industry into the future. And then we'll be looking at, starting at the edge level, looking at how we collect data at the machine level, and then going into IP architectures, not just wired topologies, but wireless as well. We've been getting a lot of inquiries for buildings, especially older ones that have challenges to wire retroactively to look at wireless technologies. We'll ultimately see how all the systems come together. We will be looking at how things are programmed, a very quick look at it, looking at the programming tools. And ultimately, Michael will elevate this whole BAS system and talk about IoT platforms and how the BAS is taken into the enterprise level, especially from the perspective of building owners, to collate different data sets, not just from the building automation system, but different other data sets that the building owner wants to see and how they actually work together. So once we set the foundation today, so stick with me on it. Day 2, we go into smart workspaces, smart sensors. There are a lot of new sensors out in the market that speak the language of IT. How do we bring that into the OT world? How do we make sense of that and use that data in collation with the data that's already coming from the BAS system, and create algorithms and create situations or programs that make all of these work together. We then go into how to configure a smart space. We talk about the world of APIs, which is pretty much the bridge between the OT and the IT worlds. My guest tomorrow will be Russell Horowitz from Somfy, and he will talk about how he integrates blinds into the BS system and largely into a smart building. Ultimately, we leave you with how to specify or helping you specify your Division 23 and building a Division 25 spec. And I'll leave you with some resources about how to, about our spec building tool, as well as some of the new, I would say, grants and incentives that are out there that will help you as you upgrade or transform your building to make it smarter. So let's get right to it. So the biggest changing force that is driving the BS industry into the larger IT industry is the fact that they're both converging. The reason they're doing, well, let me go back a little bit into history, where historically BS systems or controls equipment were used for just specific automation or specific controls of a machine or a system of machines. Take, for example, a chiller system where you have chillers, cooling towers, pumps, and whatnot. So you have a controller that helps you to bring all of those together, work them together in a particular way that you want it. Traditionally, they use proprietary languages. They have very little interoperability, and they just do exactly what they're told to. They typically work with a on-off input, or a 0 to 10 volt input, or a 4 to 20 milliamp input, and not much more. The circuit boards usually have a PID logic in them, and they can do reasonably simple algorithms like turning on the exhaust fan with conjunction to an AHU, or pumps in conjunction with the chiller. And that used to be the extent of a BAS system. Fast forward to today, you have advancement in computing technology. A lot has changed. So these little controllers at the device level, at the edge level, it is now blessed with very high computing power, a lot of processing capability. Protocols have changed. Now you have open protocols like BACnet, meaning that you have much more interoperability. So all these things are kind of transforming and changing simple control systems into much more complex distributing computing systems in a building. Now, when the convergence happens, which is happening as we speak, we are talking about bringing in fiber networks, so you get very high data speeds at the speed of light, as opposed to an MSTP network, which is using a 2-pair cable and is transmitting 60 kb per second. And then you're looking at more complex web-based integrations. It's not just integrations at the ground level. You're looking at bringing data sets together at the cloud. You're looking at smart sensors, which is polling data, smart sensors like occupancy detection and those well stats that are out there right now. You're looking at data sets that have never been integrated before and are able to come together on the cloud level to create applications that have not been conceived till now. So you can see that these two worlds are converging, and the OT world is taking more characteristics of the IT world. So one of the applications I saw recently that we did was using these occupancy sensors to detect how many people are in a bathroom, so that we programmed the BAS system to alert the facilities team that, okay, this many people are in the bathroom at this time. Please send an alert to whoever is crossing that threshold to not enter the bathroom right now, or give them an alert that, hey, there's more than 5 people there. Wait for a few more minutes until somebody leaves. And then on the same vein, depending on how many people were in the bathroom during a period of time, it then alerts the facilities team to send a cleaning crew to go and clean it up. So this level of sensors, controllers, and programming is what is making this convergence happen. So it's not enough to have technology for the sake of it. We have to know, we have to understand who this is going to serve. So we look at this from three perspectives. We look at it primarily from a facilities manager perspective, which is I know it's not the first thing that a lot of people consider, but ultimately they are the people who are dealing with a building, and it's the working of it from a day-to-day perspective, even from a KPI perspective. So they have the responsibility to make sure that the operating costs are coming down, the number of tenant complaints are coming down, and even if you consider new laws like energy laws like Local Law 97, they have a KPI to get the building to comply with some of these things. So a lot of the focus is on the facilities manager to make sure that they have the tools with them to get the building to operate the way it should be. So we take a lot of care, or when you design a building, you should take a lot of care to look into their day-to-day aspects, not just to have the machines work on day one and then forget about it, but rather you have to think of a team of people who's going to manage that building for 20 years. Can I equip them with the best tools that help them do their job in the best way possible? The second perspective we looked at is the owner. The owner has put an investment into a building. She's looking to maximize the longevity of her assets, and also to maximize return on investment by putting out a good product in the market. So take New York City, for example, you have Hudson Yards that has come out with phenomenally modern buildings. So the onus is on the rest of Manhattan to kind of upgrade and spruce up their offerings in order to match what Hudson Yards is doing. So a lot of them have, we are working with a lot of them to build up their capabilities or smart capabilities, retrofit a lot of the old systems, and bring smart capabilities to their spaces. So they're looking for certain things out of the smart building, and then ultimately the occupant, that's the taste of the pudding, the person who's paying to be in your space. Now they're paying for not just for a good environment, but these days in an ultra competitive environment in a market, they are also paying for a good experience. So maybe the coffee machine or the water dispenser is not enough anymore. They are looking for a smart app that is going to help them navigate through their space, get them through the day, or become more productive. So all these things have to be considered as these three stakeholders come together to use this building. So today we are really focusing on the first two characters, the FM person and the building owner, and taking a look at the features of a smart building from their eyes. So let's go down to the system level. We're going to break it down from the fundamental unit of a smart building, and then go all the way up to a large building architecture, and then to the IoT platform. So the fundamental unit, a system controller, something that looks like this. Now, traditionally, again, like I mentioned, they used to be very specific functionalities for just controlling a plant, or maybe a VAV box, or some kind of equipment. So it's very functional, very specific to that particular function, but not much more. And then you daisy chain all these different systems, bring it to a supervisory level, and then that's pretty much the extent of what a controller used to do. Today's controllers are vastly different. In order to have a smart building system, you not only have to consider what are the things that you want to control today, but you also have to consider the technologies that may come out tomorrow, and making sure that a controller that goes into a building that's going to be there for the next 15, 20 years is able to accommodate that new technology and figure out how to work it all into its own ecosystem. So it has to go beyond just a simple PID programming loop, or a simple input-output device, into something much more complex. So take this controller, for example. We are looking here at a 4 gig flash drive, a 512 MB RAM. So, what's going to happen is you also want some kind of expandability. So this particular one, is modular, and you can add up to 20 modules and control up to 320 points. Now, like I said, it's not enough just to control a plant or just one system. It has to do multiple things. So in this case, you want it to be able to do a complete smart room control solution. So whether it's controlling the HVAC, thermostats, lighting, and shades, you want it to do that as well. But you also want it to be able to integrate to any kind of a Modbus system. So take your energy meters, any kind of VRF systems and things like that. So you want all that to happen as well from the same controller. Then after, beyond that, you want to be able to connect any kind of IP system. Maybe you want a touchscreen. You want to have some kind of display for the room or for the FM to be able to control the space or be able to configure something. To elevate it beyond just the OT realm, you wanted to have an API embedded in it so that it can easily communicate to third-party IT applications. And beyond that, you wanted to have some wireless capabilities, not just for wireless room sensors or wireless, continuing a wireless network of controllers, but also for any kind of hotspotting, or you want to wirelessly program this. A lot of times when we commission buildings, we see that the engineer has to go to each controller individually, hardwire into it, and then use the laptop to program it. But in today's world, you should be able to take a phone, hotspot it into any wireless controller standing anywhere, and then be able to change configurations or change set points remotely. So you save a lot of time. It's much easier. So that level of convenience and control and flexibility has to come at the fundamental level, which is at the controller level, in order for a building to be smart. Oh, I did forget to mention, if you have any questions, do throw it in the chat box. We will get to it at the end. If not, we will get to it after the session is over. Now, once you have the fundamental building block, it's about building up the network. So it's really getting your machine room together, getting all the chiller and the HVAC components into the controllers working together. This is what I'm looking at is an IP system. So what is going to happen is every time you have a certain number of controllers or a certain number of networks together, you're going to start to have switches there. This is very different to an MSTP system, which does not rely on switches. But this, when you start adding switches and you look at IP level control, you are looking at much better security, much better control over the whole system. So you're building up your controllers, you're building up your system. So starting from a machine room, and then you're going to add all your floors. So whether it's VAV boxes, VAV controllers, any other room level machines that you want to bring into the system, you're arranging them to come into different switches, and you're building it up as you go. Finally, all the switches are then connected to a router, which is where whether you connect your server room, which is already in the building, or you are connecting it to the internet, to a cloud off-site. And ultimately, from the server room, or from your server, or from the cloud, you are driving applications that are going to help you manage your building, or whether it's going to help you have enhanced features like occupancy and scheduling and things like that. So this is pretty much how you build up from a fundamental level into a whole network for a building. Now, typically, what I recommend to people who are designing is, if your building is above 5 floors, I would recommend the riser to be fiber. It just helps with not just with speeds and with better performance, but also it kind of gets you future ready, because you don't know in 15 years what technology this building is going to have and how much data you are going to have to transfer up and down the building. So I always recommend the vertical stack or the vertical riser to be fiber, if you are going above 5 floors. The horizontal one, I recommend just Cat 5 or Cat 6, just because I do not, foresee more data than that at any floor. But the other thing to notice about this is that these 4 gig controllers, each of these are 4 gig controllers with 512 MB RAM. When you start to pile all of these together and you expand this network, you are starting to get a very, a very capable distributed computing network. So when you aggregate all this RAM and all this memory, you could do a lot of calculations, a lot of features at the building level without even taking anything to the cloud. And that's where I feel the future is going to be, where you can do much more at the building level without taking a lot of data to the cloud. Wireless is become very important these days. We get a lot of projects inquiries, especially with older buildings that are historic in nature or have difficulty doing risers, doing pulling cable. So we really have, it's really important to focus on the wireless aspects when you're trying to design something, because you never know where and when you can or cannot pull cable. So we look at different features as far as wireless is concerned, whether it is to hotspot a controller and be able to wirelessly configure it, whether it is to make a full wireless network of controllers and have no wires between them because you just can't pull cable or it's cost prohibitive. So you want to have controllers communicating among each other, or creating a mesh network that is that does not need cables to go between them. And then you might sometimes want to have combined systems. We just designed a museum recently, and because it's an old building, they had areas where they could pull cable, and they had areas where there were thick walls they just couldn't break. So we had to design a hybrid system where you have part of it cable and part of it flowing wirelessly. And then sometimes you want to, have more, again, a hybrid system where you want to have different IP devices connected to the controller, and then also have the wireless capability as well. So we've all seen, probably everybody here has seen some level of VAV boxes. They're usually, pretty standard, pretty straightforward equipment that just has it has a sensor input, and it has an actuator built in that then turns the damper, open or closed depending on how much air or how much heat or coolness that you need. Those days are gone. So this is not your usual VAV box anymore. What's happening now is they are, again, taking on multiple capabilities. They are able to take in sensing, not just from a simple temperature sensor or a pressure sensor, but actually from these multi-sensors that give different data sets like motion, temperature, lighting, and then it ultimately then also is able to, through Bluetooth, connect to room sensors or apps that give them inputs or outputs. Say, for example, a room that we have set up like this means you can walk into it, take your app, take the app out, and then change the set points or the blinds or the lighting in the room. And basically what it's doing is it's transmitting a signal through Bluetooth to those sensors, which then talks to the controller, and the controller is able to take the decision in the room on how to control the different aspects. So it's changing from just a simple temperature device or a simple VAV device into something much more complex. So think about this: if you add these sensors to the room and you have a mesh of these sensors connected to a VAV box, it starts to give you wayfinding capabilities. So it's able to, through the app, help you, go from one place to another in the floor or one place to another in the building. So it's going way beyond what a simple VAV controller does, and is able to do multiple things wirelessly. It's not just enough to do Bluetooth or Wi-Fi. It's there are other wireless protocols as well. So in this case, Inocean is one of the most open wireless protocols that we tend to use. And again, not just through Bluetooth, but through Inocean, you should be able to control the room, a sensor. Sometimes it could be a flow switch or a leak detector, but wireless capabilities enhancing is really important in a lot of use cases these days, as we see. Bringing it all together into a flat IP architecture, this is what we end up with, and you can kind of piece together all the little components that I said, and it's bringing it all into one place very seamlessly. I'll go very quick because we're almost running out of time. So you might inherit, life is not always perfect. You might inherit some MSTP architectures in certain buildings. Worry not. What we end up doing is using a supervisory controller to bring that into the IP network and ultimately gain control. And a lot of times, a smart building architecture ends up looking like this. I know it's a lot to digest in a few minutes. So I always encourage you, reach out to me. I can always help you to design this and further. So I'm going to run through this as well. This is ultimately a lot of it lies in the programming of it. So bringing all these together, the different sensors, different inputs, outputs, but having a freely available programming tool is important for the facilities manager to be able to change things and to configure things on the fly as things change, and not always have to call a branch office to get the quote to do simple configuration changes. So that's something that should be taken into consideration while designing, making sure that the programming tool is freely available. I'm going to run to Michael as we just reaching time. So again, having a BAS platform that helps you to easily do the graphical user interface, and also having easy operations on changing things, alarms, set points, and things is fundamental. But this is just one piece of a smart building. I'm going to hand it over to Michael to go into the IoT platform.
Great, thanks Anup. Again, I'm Michael Anselmo. I'm the Senior Account Executive with Acuity's Intelligent Building Group. And I'm going to briefly discuss what considerations you should be giving to an IoT platform for buildings, so you can really learn to leverage all this data that now you can so easily access. First of all, IoT is a really broad term, and at its basis, an IoT platform needs to be agnostic and have the ability to ingest and normalize a wide range of data, not just the data that's coming in from your BAS system, but from a lot of the other types of sensor networks that you're going to have on a property or even across your entire portfolio. So you should ideally look for a platform that's purpose-built for buildings and their assets and their sensor networks. But whatever you choose, you have to really keep a couple of key features in mind. One, when it comes to IoT, security is number one. So it needs to have a robust enterprise data security network and user manager network. Two, you have to be able to centralize all these different types of data that you're going to have across your building and your platform. And it really needs to allow for global access to normalize data through a secure REST API. And finally, back to one of Anup's points, it needs to be future ready. So it should have a structure that enables you to really enable new applications as they develop. So as you see here in this slide, it should bring in building system data, sub-metering data, operations and maintenance, and utility data. Go ahead to the next slide, please.
Sure.
When you look at, that's all right. When you look at the features of an IoT platform, it's going to allow you to do two things when it comes to building specifically. How you tactically manage your buildings on a day-to-day basis, looking at scheduling, what types of systems are working, bring to the forefront different kinds of alerts. And then it should allow you to really plan for a strategic capital investment and improvements, ongoing and retro commissioning, measurement and verification of all these different kinds of projects. So it's going to start with this top level, these different types of integrations. It should have a lot of different services, not just warehousing that data, ensuring that you have a complete and whole data set, but bringing in different types of structures, whether that's utility pricing, baseline models across your portfolio, weather normalization, robust analytics, alerts and notifications, really giving you a single source of truth and a single pane of glass for your portfolio. And finally, is you do all these things in an easy cross-functional way that enables teams and applications to grow with the buildings. And Anoop, I think that's, for me, that's just a good high-level application, and always available to talk more about that.
I'll just transfer over to you for the little demo.
Sure. So what I'm going to briefly do, I know that we're reaching time, is just give a couple examples of what this looks like. This is Building OS. This is the Acuity Intelligent Building IoT platform. And it always allows you to see a lot of different types of data and very easy to use configurable applications. But it's going to show you things like portfolio level application and asset and resource usage. And it's really built up of these, what we call cards across dashboards, to make it really easy to understand your data and identify places where maybe you want to dig in, being able to look at the same kind of data on a individual building basis. So you can see when you have all this granular data coming in from your sensor network, from your BAS system, how do you start to understand that? How is it easy to look at it and really start to take action on it? Even getting down into the asset level, if you want to say, do something like a chiller plant optimization, or start to provide reporting, whether that's internally or externally. We have a lot of system integrators that really utilize this to help with their services business, but also with those customers who are using this on a platform basis to really understand what's going on. And even today, when we start to understand what's going on in buildings with things like internal air quality, how can I really leverage that data that's coming in from my entire sensor network? And why do people care today? I mean, this is such an important question, whether it's looking at things like ventilation and those air changes, humidity, filtering, and really getting into some of the nitty gritty, whether it's even something like scoring a air handling unit. But that's just a very high level overview of how you can go from a very macro to micro level in understanding your buildings, their assets, and the different systems and system networks, and what it should look like and how you can really understand it. Thanks, Anoop.
Thank you, Michael. So the IoT layer sits a level above the BAS system, and Michael is able to pull the data from an IP BAS system in order to populate the things that his platform needs to see or the owner wants to see from that perspective, but also to get in, collate it with data like energy meters, energy bills, and multiple other enterprise needs that the owner might have that he wants to see or she wants to see way over and above just a simple BAS system. So that's the real value of bringing that layer in. For Michael, it's an easy integration to pull that data from any BAS and represent data pretty quick. The other piece I just want to share before we close is Michael's solution, Building OS, is a NYSERDA certified service provider, and Distech is a NYSERDA certified system provider. Now, those who are trying to pursue projects that require or are looking for rebates from New York State, this is the mix that they look for in terms of availing some of those rebates that go up to $200,000 or 30% of a project value. So these are some of the ways that a lot of the upgrade projects find value in some of the funds out there. So with that said, I just want to close today. Thank you all for joining me and Michael, and I will see you all tomorrow. Thank you very much.
Thank you. Have a great day.